Find an equation in standard form for the ellipse with center 6, 4, horizontal major axis of length 10, passes through the point 8, 2. So I'm going to start by drawing a picture. It's not absolutely required, but I think it'll sure be helpful. So here we go. Something like that, okay. And then we want to locate, so we're going to the center is 6, 4. Okay, so 1, 2, 3, 4, 5, 6. Up 1, 2, 3, 4. So right there, there's the center. 6, 4 for the ellipse. And it says horizontal major axis length 10. So that means the horizontal axis has a length of 10. So in other words, you go 5 to the right, 1, 2, 3, 4, 5. There's 1 in point and 5 left, 1, 2, 3, 4, 5. So I want 5 that way and 5 that way. And that makes the horizontal, right, that means sideways, axis total of 10, right? You with me? This is 10 all the way now, just like they said, horizontal major axis of length 10. So, okay. And then they say it also goes through the point over 8 up 2. Let me locate that point. This is 7, 8 up 2 right there. So that's a point that the thing goes through. So that means when we go to draw the thing, which I'm going to sort of try to do now. Kind of, yeah, hey, that's not bad actually. Well, it looks more like an eyeball, but whatever. It sort of looks like that. That's sort of how the ellipse works. It goes through this point 8, 2, right? That's on the edge of it. And it has center 6, 4. And it goes right and left 5. And what do they want? They want find the equation. Okay. How am I going to find the equation? Well, if we go to the notes, I just updated the notes for you and sent them out to your student email. And they're also on the top of the Unit 5 module, the Exam 5 notes. So let me grab those. They're new and improved. Did it just an hour ago. So here they are. I'm excited about them. I went on the internet and searched and added some of my own stuff to it. So here's the Exam 5 notes. So basically it shows how to graph, I'm showing graphing an ellipse centered at the origin, like that. And then down here I show graphing an ellipse not centered at the origin. And that's what we're talking about in this one. So let me grab that one and bring it over. So graphing an ellipse not centered at the origin. Okay, so graphing an ellipse not centered at the origin. How do we do it? Well, the center is the opposite of the numbers next to x and y in the original equation, right? So when you have like -2, the center becomes +2. See this? -2, +2, and +5, -5. See how they just go opposite, opposite? Remember that? So the center is the opposite of the numbers next to x and y in the original equation. Okay, so we've got center, 6, 4. So that means it's going to be x -6 squared over some number plus, let's say some number, y -4 squared over some number equals 1, right? That's the general form of the equation, right? You have x plus or minus something squared, y plus or minus something squared over different numbers equals 1. Right? That's the form when it's not centered at the origin. Ours is not centered at the origin. Good so far. See how that's the opposite? Right? If I go back to this is +6. So it's opposite. Same thing here. This is +4. So it's opposite, right? So that's what it's saying here. It's saying the opposite of the numbers next to x and y in the original equation is the center. We see it right here, -2, +2, +5, -5. Okay, so we got that much. Now, what goes underneath x and y? Well, and we read right here, from this center, go right and left the square root of the number under x. See this number under x? When you square root it, 6, That's how far 1, 2, 3, 4, 5, 6, right? See that? And 1, 2, 3, 4, 5, 6 left. So it goes 6 this way and 6 that way from the center, because that's X. That's what's underneath X. X is always right, left. You go right, left for the number under X. You go up, down for the number under Y. X is always right, left. Y is always up, down. So we go right and left, the number underneath X, the square root of it anyway. So right down here, the square root of some number is right and left 5. So it's got to be 25, doesn't it? You see that? Because we know from the center, you go right 5 and left 5. And so I shouldn't write square. I should just write, oops, 25, because the square root of 25 is 5. How are we doing so far? Is this good? Right? Again, one more time. Whatever's underneath X, the square root of it is how far right and left. Square root of it. Okay, well, we already know how far right and left is 5. So the square root of this is 5. It's right. Okay. Last thing, we need to find this. Call it b squared. Call it Joe. You know, whatever you want to call it. Call it b squared. That's what we're trying to find. That's all we have left to go, and then we're done. Okay, right? Because they asked us to find the equation. We've got the equation. We've got every part of it except for the b. We just need to find b, and boom, we're done. We got the equation. Now, how are we going to find b? Well, we don't know right now. There's one fact we haven't used, and that is that it passes through the point 8, 2, right here, right? 8, 2 is on the edge of the hyperbola graph. I'm sorry, ellipse graph. Hyperbolas are coming next. Ellipse graph. This is an ellipse, right? It's an egg shape. We call it an ellipse. Like the planets go in elliptical orbits around the sun, right? Not a perfect circle, but like a oval. That's right. There's all kinds of things in the real world that operate in elliptical fashion. So that's why these equations are made up in math, to describe things in the real world that do elliptical things, like planets going around the sun. And there's many others. This point, 8, 2, is a point on the ellipse. Now, what does that mean? So what? Well, that means if you plug in, change my color, here we go, X to be 8 and Y to be 2, it's got to make the equation true. That's what it means to be on a graph, any graph, not just an ellipse, right? I hope that's 100% clear to you. If you have a graph of a U-shape, say, what is a U-shape? A bunch of millions of different points. If you have the graph of anything, blah, 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 whatever, it's millions of different points, and all those points make the equation true. That's what a graph is, a picture of the millions of dots that make the equation true. So if a dot is on a graph, like this dot right here is on the graph of the ellipse, right? It goes through the point 8, 2. That means the X and the Y, the 8 and the 2 plugged into the equation, 8 and 2 plugged in for X and Y, have to make the equation come out equal, come out true. Otherwise, it wouldn't be on the edge of the picture. It wouldn't be part of the picture. I shouldn't say edge. It's on the ellipse. It's on the oval. It's on the egg shape. It's on the ellipse, right? It's one of the points on the ellipse. So therefore, it's got to make the thing true, or it would not be in the club. So, all right. So that means 8 minus 6 squared over 25 plus 2 minus 4 squared over b squared is 1. Simplify that. That's going to be 2 squared. I'm just going to make it 4. 4 over 25. That's going to be 2 squared again. 4 over b squared is 1. Okay, we get to there. And now we need to solve that equation. How do we solve that equation? Well, are you okay with fractions? This is a really important part of this class, is getting you more and more comfortable with fractions, because they're going to go crazy in pre-calc and calc. You need to know fractions. So when you have fractions with an equal sign, like we do here, there a little far. What do? Step one, you multiply all the terms by the LCD over 1. What's the LCD? It's the two denominators together. So that's going to be 25b squared over 1. You got to use all the denominators. This is the mistake I made the other day. I forgot about the other part. You've got to use all the denominators, not just one of them. The LCD, least common number, is all the numbers. So it's going to be 25b squared over 1 and 25b squared over 1 and 25b. You don't need to put over, I mean, you can put over 1 if you want to. Right? Is that making sense? So 25b squared over 1, 25b squared over 1, 25b squared over 1. Okay, and then what happens? We're going to cross cancel things, aren't we? So I'm going to go 25 cancels 25, b squared cancels b squared. All right, let's see what we have left over. What do we have remaining? We have 4b squared, right? 25s are gone. Over 1, we don't need that. And here, 4 times 25 is 100. So we did 4 times 25, it's 100. Over here, the 1's cancel, and it's just 25b squared. That good? No more fractions, huh? So step 1, just multiply all the terms by the LCD over 1. Whenever you're trying to solve an equal sign problem, an equation that has fractions, multiply through by the LCD over 1. Okay. Now what? Now you just solve it. Meaning what? Well, subtract 4b squared. So step 2 is just solve. So subtract 4b squared from both sides. And what happens? These cancel. And we get 100 is what? 21b squared. That's 21b squared. So let me bring that down here. So 21b squared is 100. Now divide by the 21. Boom, boom. B squared is 100 over 21. All right, so we got b squared. Now you might feel like, hey, let's take the square root and let's get b. But no, that's really not needed. Why? Look back here. This is our original equation, right? Let me get a good color here. Right up here, right? And see how he has b squared. So just stick that in. We know b squared is 100 over 21. So let me bring it down to here. So what we have now is we have x minus 6 squared over 25 plus y minus 4 squared over b squared equals 1. Okay, and then just boom, put that in. So we've got x minus 6 squared over 25 plus y minus 4 squared over b squared. What is b squared? Well, it's exactly what we're looking at. 100 over 21 equals 1. Done. Now, I know you might feel like, hey, that's pretty ugly, Mr. Heron. Yeah, it's a little ugly. It'll take it, though. It will. You can type it in just like that. They'll take it. Or, I'll say, or you could also just calculate this on your calculator if you want. Just take 100, divide by 21 on your calculator. If you prefer, if you want to get a decimal, it'll take that too. I tested them both. It'll take 4.7619. If you'd prefer to just put 4.7619, it'll take that too. So either the decimal or the fraction, either way, there it is. We found the equation of that ellipse. That's what they want you to type in. It's that equation. So let's run over that again. How'd we do it? Well, we put down the center, 6, 4. We realized that meant x minus 6 and x minus 4 squared in the top because it's always opposite. The center's numbers, it's opposite and opposite in the equation. And then however far right and left, 5, this must be 25 because the square root of that number tells you how far right and left. That goes underneath x because it's right and left. And then we had to find what goes underneath y, b squared there. So then we used the point 8, 2, which was on the ellipse. So we plugged in x is 8, y is 2. It's got to make the equation true. We got this equation, simplified it, multiplied through by the LCD, 25b squared, canceled them all out, got to here, solve for b squared. Didn't need to get regular b, just needed b squared. Why? Because b squared is what we have to plug in for in our formula. So it's 100 over 21, or 4.7619. There it is.